Okay, yesterday we talked about this concept of limit. So limit just say that what is my target as the variable is approaching to certain things, to certain value. So for example, if we got something like this, x to the second power, if x is approaching to 2, what will be our limit? It'll be 4, right? Now, if we have something like x equal to 0, we got something like x plus 1 and 3x plus 4. What we end up with?
1/4.
What's that? 1/4. So now it looks like all we need to do is just replace x with whatever the top listing, right? Right? Are we good here? Are we good here? So far, that's what it tells us, right? And so, therefore, we could say that in general, if x is equal to c, we find this value of x of c, which equals to f of c, right? So, this is called finding the limit by substitution.
I'm waiting for it.
Okay, so basically we just do that, right? Are we good here? Yes. So that's most time it works, but there is a problem. Sometimes this one doesn't work, which is basically what our derivative is. In derivative, we cannot do substitution. So, for example, what is x? As x goes to 1, we have x minus 1 and x squared minus 1.
You're not allowed to do that.
Well, the limit is still valid. But what happens to f of 1? F of 1 is this function defined as x equal to 1? Yes? No? Is this function defined as x equal to 1? Why is that? Because bottom is 0, so this one is not defined at this point. We say this is not defined. Defined as x equal to 1. So therefore we don't even have f of 1. So we cannot do substitution. Right? So what we're going to do with it? But do we have a limit there? Yes. We do have a limit. If you graph it out, we end up with something like this. We end up something like this. X is 1, this is 1, this is 2. Right here. Let's do that a little bit better. If we graph this out, what it ends up is this kind of function. 1, 2, 1, 2. So we end up with a function like this. And right here, we got a hole here. Right here we have a hole. Right? Because it's not defined there. Right? But this function definitely has a limit right at this point, which is not function but not defined. So therefore we end up with a situation we cannot do that. Ends up with a situation x to c fx that is not equals to f of c. So we do have run into this situation. Right? You good so far? You good so far? Now, what is the limit of this function? Yes?
If you put 1 in as the limit, doesn't it just become 0 over 0?
Right, that's why it's not defined.
So what do you mean, what is the
But
limit?
the limit is still true. There's still a limit.
So anything that's
So as
not
x
1?
approaching to 1, what is y approaching to?
A hole.
It's a hole, but what value is approaching to?
1, 2, 0. 1.
2.
What? Which way are we going?
Either way. We can either go from this way or can go from this way. So that means we either go approach from this side or approach from that side. But no matter what, we're approaching to a fixed value. We're approaching to what? 2. So the limit exists. This doesn't exist. Exists. But this is undefined. So that why this is not equal. We cannot use substitution. Okay? And in order to find the limit of this one, we have to do this. We have to do the limit x go to 1. This is x minus 1. The top, remember, we can write as x minus 1, x plus 1. Right? Right? You guys know this? This you guys should know. If you ever claim you have learned algebra. If not, that means you don't know algebra. This you should know. Right?
You don't know, you should probably know.
That's something you should know.
Good one.
Okay. All right. Good. So, if you learn something and you forget about it, that means it's the same as you never learned it. Okay. Probably even worse, because you think you learned it, but actually you don't. Okay. So then what can we do here?
Reduce.
Why?
X minus 1 and x plus 1.
And the reason we can do it is because x is not 1. Right? That's the only reason we can do it. If it's x equal 1, we cannot do it. So,
Negative 1.
do I have your attention here, everyone?
Yes.
This is very important here. So because x is not 1, we can cancel this. Then we end up with something different. We end up to limit x equals 1. This is what? X plus 1. And that we can substitute, which gave us what? 2.
1.
So we definitely can find the limit, even though it's not defined. So now, what that means about what we just learned.
Can we scroll back up a little bit to see the process?
This one? Well, we start with this.
Yeah.
We start with this.
We went from a hole and then
Right.
we can define it as a hole.
We have a hole. The function as x1 is not defined. Right?
Oh, I remember this. And then the hole, and then we got rid of the hole and then
Okay. But we do have a limit.
Yeah.
Because on both sides we know it's getting to the y is getting to 2. We just don't have that as a function. So the limit exists. And by doing that, we factor this into x minus 1 times x plus 1. And x minus 1, x minus can cancel.
Where did
This?
Sorry.
Huh?
The original x minus 1 over.
Yeah.
Oh, that is just that line.
Yeah.
That's right. Okay, never mind.
But this one can rewrite as this.
Right. Yeah.
But since x minus 1 is not 0, we can cancel. This is exactly what we did with the derivative, right? Remember that h? H is is not 0. But in the end, we make that into 0. Okay? So, but the only thing works in math is because we are talking about a limit. So when we're talking about a limit, then the limit, we do have a limit at, so the original function has a limit at x equal to 1, right? It has a limit, but undefined. But undefined at that point. Okay. We good?
How do you define a limit? As in, like,
A limit?
what is a limit?
Limit is whatever the target the function is going to.
It's a target.
Yeah, it's a target. Like here, when x equal approach to 1, the function, the value of the function actually getting towards 2. And 2 is our target, so that's the total limit.
But at x equals 1, the limit isn't technically 2. It's infinitely close to 2.
No, the target is 2.
Well, the target is 2, but at x equals 1, for this function,
It's not defined even at that point. The function is not defined at that point.
you're right. But the limit,
Well, but as x approaching to 1, the value of the function is getting ever so close to 2.
it's not, okay, so by limit you mean it doesn't actually get to 2.
By limit, that's the target. Just show that's the target.
It's a target but never actually gets
You may not get there.
there. Can you get it?
Sometimes you can.
You can have a limit that you reach.
You can get to.
And
This,
what case with
this is what we had at first. This. Now this. So the limit is the same as the function at that point. So in that case, the limit is something can get to.
Okay, so here, the limit isn't technically 4. No, it's 1 before.
No, this one?
No, the one before.
One before. The limit is 4. Because as x goes to 2,
Okay, so
x squared goes to 4.
in the function, when x equals 2, the function doesn't technically equal 4 though.
Yeah, f of 2 is 4. 2 squared is 4.
Okay.
Right?
Yeah.
So in this case, the limit equals to the function. So in this case, we can get to that. The function can get to that point, can get to the limit. But not in this case. In this case, the function can never get to that limit. It's just a target that function is getting ever close to.
Alright,
We good? Make sure that that's why we're talking about limit. Limit is the target, okay? As the variable changes, what is our value of the function going towards 2? Right? And that's what we call a limit. We good? So now we actually got two situations. In one scenario that we have this. We have this. And that's one. But another scenario, this is not true. We still have a limit, but this is not true. Okay? So, the difference between these two scenarios is this is true if the function is a continuous function. This is true if the function is not continuous. Let's give an example. Exactly that function we had before. If fx is equal to x squared minus 1x minus 1, this function now this function 1, 2, 1, 2. This function has a hole here. So this function is not continuous. But this function is continuous. Right? So this works for the first scenario. We can substitute x equal to 1 to find the limit. Right? But not this case. But the reason for this is because this function is not continuous. So any function is continuous is the first case. If it's a continuous function, we can use substitution to find its limit. Right? But if it's not continuous, we cannot find, we don't have value, so we cannot use substitution. We have to change it into different function by canceling x minus 1 to get the second function. right? And then we find the limit that way.
Aren't they technically the same function?
No.
Why not?
Most places not the same, except as right here.
But mathematically, you didn't really change senorita.
Well, I changed that to this. Remember, on the second case, we changed this to this. We said x squared minus 1 over x minus 1 is equal to x plus 1. But this only works is
Oh,
not 1.
okay. They call me pretty much.
It only works in this, in that domain. This is only true in this domain, but not at x equal to minus 1, x equal to 1. Make sense? So they have different functions, right? Why is this? Why is this? They are different functions. So if it's continuous function, we good here? If it's continuous function, then we can use substitution when you find the limit. But if it's not continuous function, we have to do this canceling. We have to play that trick and turn that function to a different function, which is continuous. Like this is continuous. And then we can use substitution. Okay? We good? We good? We good so far? Well, so sometimes we'll say, oh, does it always happen that if there's a hole?
Wait.
Yes, it's not defined. Yes.
Is it not the bracket because it's a hole?
There's a hole, yeah.
But is it not a bracket?
No, because we cannot include one. Not inclusive. That's why we use open bracket. Because one cannot be there. Right? We good? Because these two functions won't be true at x equal to 1. That's not true. This cannot be equal. Right? One is true, another one is undefined. We good here? So that's the general principle. If a function is continuous, you can use substitution to find this limit. That's a simple one. Right? You just replace x with whatever the value the x is approached to. But if it's not continuous, you have to do that trick. You have to do the canceling. Then find it. But not always you find the limit. Okay? Sometimes there is no limit. You cannot find it. For example, if I have a function like this, this is our function. What is the limit as x goes to 1? What is that function? Do we have a limit here?
-1.
If you go to the left-hand side, you get to 1. If you go from right-hand side, you get -1. You get two different answers, depending on which way you go. So in this case, there's no limit. This function has no limit. Right? We good on this one? Because from left, we get 1, from right, -1. That's not the same thing. Only time you get a limit is from left to right give you the same.
Continuous?
Not necessarily continuous. Continuous functions always have a limit. But these continuous functions can have a limit if you get to the same point from both sides. So for example, if I got this, if I have this function, this is 3, this is 1, this is what kind of function, guys? Someone learned that? Absolute value function. So if this function, the limit x goes to 2, what this function goes to? What's the limit?
I don't know.
From the left, we go to where?
Do you mean x equals 3?
X equals 3, but when we from left,
I mean in the limit.
oh, sorry, yeah.
Okay. 1.
1. How about to right?
1.
1. So therefore we have limit as 1. Okay?
Alright.
Is that we clear on this limit thing?
Yes.
You have to go from both sides. Okay. Otherwise, you get different value from both sides, then there's no limit.
No limit.
Yeah. limit has to be equal approach on both sides. We good? Okay. So here is some works for you to do.
Just don't make eye contact.